examples of the quotient rule. So let's now apply the rule that we just proved. So in example 4, it's asking you to find the derivative. You can use multiple notations. I'm trying to switch it up every now and again. So in this case, maybe we'll write y prime is equal to, and remember, it's ho d high minus high d ho, draw the line and square below. So ho, that's the low one, that's the one on the bottom, x squared plus 4 times, so ho d high, the derivative of the high one is 3, minus high, that's the whole thing, 3x plus 2, d ho, that's the derivative of the lower one, so that's 2x, draw the line and square below, like that. And then you just simplify. Now, for most of if it was just asking you on a free response for the derivative, you would be done right now. If it was asking at a set value, you could also just plug it into where it is right now. But most of the time, this type of question will be the multiple choice of the AP exam. So, and the same for me when I give you an exam. So, you need to practice simplifying this out. So we're going to do that. Negative 6x squared, let me check here, minus 4x, I guess it would be, over x squared. Do not multiply out the denominator because the preferred form of derivatives is actually the factored form, believe it or not. So it's negative 3x squared minus 4x, did I get the sign right? I think I did. And then plus 12 over x squared plus 4 squared. And the reason why we like it in factored form, it's much easier to find where the derivative is equal to 0, which becomes very important later on in finding possible relative maxes and mins. Also where the derivative's undefined also becomes important, so that would be when the denominator, and it's easier to find those if you have it in factored form. All right. Pause it and then find B on your own. I'll go grab it over here. Scooch it. So that's what I got for part B here. Oops. All right, let's try number 5. So this one we have to pay attention because it says find the equation of the tangent line to a graph of each of the functions at the given point. So first we have to find the derivative. Some people like rewriting the function first. F prime of x is equal to 4 minus x to the negative first over x plus 2. Or they like having it not be a complex rational expression on the right, so they multiply the numerator and the denominator by x. To me, it doesn't really matter. I'm just going to leave it. So we're going to do f prime of x is equal to ho, that's x plus 2, d high, so the derivative of 4, that's 0, and then the derivative, a negative x to the negative 1, is going to be x to the negative 2, because negative 1 times negative 1 is positive 1, minus high, 4 minus 1 over x, or let's call it x to the negative 1, d ho, is 1 over x, so draw the line and square below. There we go. Oops. Texting here. Then we have f prime of x is equal to, we're going to do some simplification. In this case, we would have, you know what? In this case, I don't think it would matter to simplify, by the way. I would probably multiply the numerator and the denominator by x squared, so you didn't have a negative exponent. If I was trying to simplify, but it's not actually, so I'm talking out of turn here. It's not actually asking for that in particular. It's not asking for the derivative in and of itself. It's asking at a point. So this point here we have at 1, 1. I'm going to just substitute it in. Even though it looks messy, I'm going to substitute it in as is. So f prime of 1. Don't forget to use proper notation. We're finding it at x is equal to 1, so you're going to write f prime of 1. And then just substitute in here. 1 plus 2 in parentheses, and then 1 over 1 squared is the next one, which is x to the negative 2, minus, and then we have 4 minus 1 over 1 times the 1 I don't need, and then we have 1 plus 2 squared. So I'm going to concentrate on simplifying that. That's going to give me a 3 minus, ooh, what do we get here? Minus a 3 over 3 squared, which is actually 0. So that means we've found a place where the derivative is actually equal to 0. So in this particular case, it's going to be a horizontal where the slope is equal to 0. So I know that if it's a horizontal line, it's asking you for the tangent line, it's going to be y is equal to whatever the y value is there. Y is equal to 1. And that's, do not box your answers. I'm still seeing people on the free responses boxing answers. All right, part B, I didn't make it work out so nicely that it was just a 0. It becomes an actual line. But I want you to give it a shot. Hit pause right now and give it a shot on your own, and then we'll talk about it. Okay, so here, let me move this. Whoops, I didn't mean to do that. I'm moving the two possibilities over just so you have it in the right spot, but I need to just here. I want to talk about a couple of things here, is some notation as well. So here, first of all, in the green version of this, I just rewrote it like we did before. I substituted in here, but over here, if I'm using dy dx notation like this, over here on the left-hand side, I can't just start plugging in the number 3 without indicating that. This bar here that I have next to it and then wrote x is equal to 3 is called a domain bar. So we're finding dy dx when x is equal to 3. That is what the domain bar, don't leave that off. Otherwise, you would have to write up here when x is equal to 3, dy dx is this. Otherwise, you are saying that dy dx is always this one value. So be really, really careful with that. Make sure you use proper notation. If you didn't, go back and fix it. If you did y prime notation, you're going to do y prime of 3. You're going to just use function notation for that, right? All right, so when I substitute all of these things in and simplify, I got 5/6. That means I can write the equation of a line here. On the second one over here, or not the second one, it's the same question. Another option was to rewrite this. Whoops, I've lost a negative one here. Rewrite this as, whoops, by multiplying the numerator and the denominator by x. Either I distributed the x or I didn't. I left in either one. It was just easier to square below, leaving it in factored form. But when I took the derivative of it in the numerator, I used the multiplied out version. Whoops. I meant to circle this. I used the multiplied out version. It's just a mix of the two is fine. But at the end of the day, you end up with the same answer. So either way, it's fine with me.